look at prisms again. So, the gist of yesterday was kind of throwing it out there with all the shapes that we're going to do. Now we're going to specifically look at each individual one. So the first one's going to be a prism. So, think about this from yesterday. And what were our most important things that we had? Are you okay if I turn this off? It's better for that glare, but if you need it on back there.
2 parallel bases.
I can see.
Okay. Then we're good.
Yeah, pretty much.
What?
2 parallel bases.
Okay, so we have 2 parallel, and what else?
Edges.
About the bases. About the bases.
2 bases.
They're always rectangles.
They're parallel and what?
Rectangles.
Congruent, right? They don't have to be rectangles. They can be anything we want them to be. It could be a rectangle. Remember now, the base is how I name it, so it can be any shape. And this is how I name it. So if it is an octagon, then it's an octagonal prism, right? And a lot of the times we want these to be regular polygons, right? At the bases. What are all of my faces then?
Rectangles.
All the faces are always rectangles. And so this is where it gets confusing when we have a rectangular prism, right? So if we go back to our Kleenex box, or just the box in general, this is why it's confusing, because we could have 3 different perspectives, right? That the base is what it's sitting on my hand right now, or it could be the 2 outsides, or it could be the front and back. Essentially, what we're going to do today, it doesn't matter which one you think it is. You just have to recognize it. Now, if it's a different shape, right? If it's a pentagon, if it's an octagon, whatever, then you automatically know that that is the base, even if it's not sitting on it. So if this side right here was a pentagon and this side right here was a pentagon, they would still be congruent. But even if it's sitting like this, my bases are these 2 outsides, because that's not a rectangle.
But you said for it to be a base, though, it's got to be parallel. It's got to have another parallel.
It's got to be parallel to it and congruent to it.
So in that case, any of those sides can be a base. On
Yes.
the box. Or-
Absolutely. Because this is a rectangle.
Oh, so they're all.
So if it's a pentagonal, then my pentagons would be here or here, and you would definitely know that they're pentagons.
Yeah, you have to.
But then everything else would be rectangles.
Yeah, but then those pentagons would be your bases.
It has to be. Okay? And so then you don't necessarily need a regular pentagon, but it's easier if it is. What do I mean by a regular pentagon? All the sides and all the angles for that pentagon would be the same thing. So the bases are always going to be congruent to each other, but they might not necessarily be regular whatevers. Okay? So then, that's what we kind of talked about yesterday in the gist. Now we're going to introduce a height. A height of a prism. How do you think we describe the height of a prism?
How high? It's like
It's the
Tall.
height of the
altitude.
base.
Obviously, it's, okay, so, good point there. We could call this the altitude, if you wanted to.
Oh, it is.
Okay,
What were you gonna say?
Nothing, 'cause I didn't know.
Oh, good.
so, now listen to me though. What happens if we look at this right here, and these are pentagons again, okay? If these are pentagons where my hands are, but it's sitting like this, the pentagons are still my bases, right? So what's the height?
The rectangle, the edge of the rectangle.
It's
Not
your
the
face.
pentagons, you'd be used.
Well,
Use the face.
It's up and down?
yes.
So is this the height?
No, it's going this way. So like if you were to put on its pentagons, you'd have to use the edge.
Base to base.
It's the height.
What?
Base to base.
Yeah,
There you go.
that's what we really want to say.
That's
So the height of the prism is the distance between the bases. That's the important part. Understand what I'm saying now? So in here, again, which one's the base? If the top and the bottom are the base, what's my height? This little piece right here. If these two are my bases, what's my height? This long side, right? If the top and bottom are, what's my height? This distance right here. So it's always the distance that is connecting my two bases, or my hands in this case.
So what would you do in something like that then? 'Cause if we're to-
You can do it any way you want, honestly.
You're starting at the same answer.
You're gonna get the exact same answer. Your height obviously changes,
Yeah.
but the difference is then, like, if I'm thinking this is my height, then this length is way longer when I do base times height of the rectangle. So it's always going to equal out, okay? All right, any questions there? So, from here then, we want to talk about a right prism. A right whatever prism. So again, when I have a blank there, we fill that in with whatever word we want. Octagon, pentagon, rectangular, or whatever. Okay, so what does it mean to you if it's right?
It has a right angle in it?
Okay, so it has a right angle in it, so what does that mean to you? Here's my question. Is this a right prism?
Yes.
Could be.
Yeah.
Could be.
What is operating?
In the book it shows that you gotta say
It's not a square. It's not a
Okay,
box.
so is this a square?
Yes.
Yeah.
I don't know. You don't know.
Not really, no.
No.
I'm not sure.
No.
It
I wouldn't
doesn't
say
say
so.
it's a square.
It doesn't say it's
You don't know for sure.
We just can't take it as a square.
right. Okay, can't assume. And to me, this side right here looks way longer than this side,
Exactly.
right?
Not really.
I think they would.
Okay. Can I say this is way longer?
Yes. that's
Okay,
what I want.
thanks. Okay, so what do we mean by right? Your concept that it has a right angle is exactly right, but not truly right. So when we say a right prism, this is where you would have regular polygons as your bases. And then they would form 90-degree angles in some spots
So like it would form a 90-degree angle with the altitude.
with an altitude. Exactly right.
It's the altitude.
Boom, boom, across. Yes. Okay? So, right prisms, you honestly want them. You want them to be, so to me, it would be what you would consider a lot of things, okay? Being perfect in a sense, right? It's what I would envision a prism being, meaning the top and the bottom, and then everything's nice and neat. Okay? The other prism that you might hear is an oblique prism. And again, obviously I should have left the space there because we could have anything. But what an oblique prism is this. So remember how we drew it previously where we had our prism? Well, my prism for this would be something like this. If I had a square here, so it could still be a right angle.
No, draw the, yeah,
So, but instead of, so like what we drew yesterday, it's still
You
not
wanna draw what's in the book?
No, I can't draw what's in the book. How am I going to draw that?
It's not really simple.
So basically, if I took this right here, okay, and this stayed exactly where it was, an oblique one is if I would be able to push this whole thing and that it's leaning over. So envision the Leaning Tower of Pisa. Can you think about that?
Yes.
So the Leaning Tower of Pisa would actually be a cylinder instead of a prism, but we're going to use that concept, how it's just leaning, but the top is still squared to the bottom, okay? So if you look at it in the book, it's kind of like in a regular prism, this would be standing on itself, right? And then my connections. And again, it doesn't match up very well because it can't do it on the board. In the one that we're talking about now, an oblique one, it would just be tilted over a little bit,
Just drawing 2D.
okay? Okay. So yes, there's my one face. My other face would look like this. There you go. Thank you.
So it's like, so
It's
say
slanted.
this is the first one, so it'd be like this then?
But this stays flat on the ground.
It's just slanted.
This,
bottom
and
is
then-
still
oh, okay. got
So
it.
the top and the bottom are still parallel to each other,
It's like your-
but it's just slanted in between them.
It's like your point of view of it.
Right. So my height is actually where in an oblique prism.
Yeah, at the 90 degree.
I got to draw it on the outside here. Because remember, a height always has to be that 90-degree angle. So here, my height is still the one that's straight up and down. So the height can be anywhere. If it's an oblique one, it's going to be on the outside. But Riley's right. If I just draw it like that, then you can still see it. So essentially, it's putting this down right here, and that's staying exactly there, and then shifting the whole thing. But then the top goes back to being parallel with the bottom. Okay? That's why I'm not an artist. Right? Make sense though?
Yeah.
Okay. Questions here with any of that stuff? So, the next thing that we talk about is the lateral area. And we're going to do this of right prisms. So the two things that we're going to talk about is the lateral area, and then the next part would be the what? The surface area. Okay, so the first thing that we want to really do is differentiate between the two. And again, we're going to try to always do this with the right prism. A right prism is going to just make it a lot easier, but you can do it to these obliques too. When we talk about a right prism, again, we want that perfect one, but what's the difference between the lateral area and the surface area?
Surface area is like you take in the area of all the shapes on the
What you can
shape
see.
of the 3D object.
Lateral's
That's
volume.
what you can see.
Lateral area is the sum of the areas of lateral faces.
Okay, what's that mean?
So all the faces of
Faces that aren't on top and on the bottom.
It's basically going.
We don't want to say top and
It's
bottom.
like the altitude bases.
It's the ones
that are
It's the ones that are,
Yeah,
The non-face.
exactly. Faces, bases, right?
Yeah.
Yeah. So, to me, this is the guts. The stuff in between my what?
Face.
My bases. So think about this. When I talked to Cam about this yesterday, because he was asking before he went on the golf thing today. And think about wrapping a gift. If you wrapped a gift and you wrapped it perfect, that would be me covering the what?
Surface area.
The surface area. I'm covering everything. Okay, because I'm even getting the sides, I'm getting the top and the bottom, I'm getting everything, unless you're really bad at wrapping, right? You got holes in them, okay? We're not that kind of wrapper, okay? The lateral area is me doing just the middle of it. Whether it's standing on the bases or my bases are out here, so I'm leaving the bases not covered.
Okay.
That's the lateral area. So to me, that's the guts, the stuff in between the two bases, okay? You got to think about it how it clicks in your melon. Okay, so when we talk about the lateral area, we're basically, I can say it this way sometimes. This would mean that I'm going to find the area of all the what?
Shapes.
Okay,
I don't know how to say it. Like,
Faces.
All faces that aren't bases.
all faces that aren't bases, that's the way, okay? Find the area of all faces, not bases. And so realistically, this should always be what shape?
rectangle.
They should always be rectangles. Now, every once in a while when we're talking about a box, then our bases are rectangles too. So, you know, that's where I'm kind of hesitant to write it that way. But all my faces should be the rectangles all the time. So if you have a different base besides a rectangle, then you're looking at all of the rectangles and finding the area of each individual one and adding them up. But if we say that it's a right prism really means that it's perfect and it has a regular polygon on it. So each one of those rectangles in between there actually are what?
Same.
Exactly the same thing.
You just do one of both kind of now.
Then you did, yeah. So realistically, when you're doing a right prism, it's way easier because then we can have a formula. Lateral area, LA, is equal to capital P times H. So what's P mean? The perimeter of what?
Of
Faces.
faces.
The perimeter of the what?
Face.
How about the base? I'm going to take the
yeah.
perimeter of the base. I'm going to add up the base. Right? Because each one of my rectangles should have that side in the problem. Right? And then the height is actually the what? This is truly the height, but what does that tell us?
Altitude?
Yeah, this is my altitude or the distance between the bases. That makes sense what I'm saying there? Okay? So again, I can't use this, right? Why can't I use this? Because none of my bases, or none of my faces, is a regular polygon. Right? This isn't a square. We came to a conclusion. So if this isn't a square, then all of these aren't the same thing. They have to be perfect in order to do this. Okay? So this is only when the base is what?
Regular polygon.
A regular polygon. A square, yes, but a regular polygon for sure. So again, when we say regular pentagon, my pentagon sides are all the same. So when it extends and has a rectangle coming from each side, each one of those rectangles have to be the exact same rectangle all the way around. If it's a regular octagon, then I'm going to have 8 rectangles that are exactly the same.
But this will, yeah, so this only works for that.
This only works if it's a regular polygon as my base.
This one is all.
Right. So a square would work. But this, a regular rectangular prism, doesn't. Then I have to do my work inside. Okay? So if you have an oblique prism, what do you got to do?
Find your altitude.
Yeah, well, no, the altitude doesn't even really, well, yeah, I still need my altitude, but you're going to find the area of each rectangle. They could be different. Remember the pentagonal prism we drew yesterday when I drew it as a house in front and then a house in the back? That truly was still a pentagonal prism. But there's no way that all of those rectangles were the same length. You know what I mean? Because my house, the sides of my house and everything weren't the same. The roof was longer than the sides or whatever. Okay? So you can still do this, but if it's an oblique prism, you're going to have a little bit more work to do. I honestly don't think there's too many of those. Or like in the quiz and the test. All right? So, does everybody okay with the lateral area? I want to show you this before we go on, because if you don't get this concept, then it's hard to see. So here's my problem.
So for something like this, we assume it's regular polygon.
No, they should tell you. See how this one says it's a regular hexagonal prism? If they don't say that word regular, then you know that you got to do more work. Okay? So again, when they say this, so if you don't understand this concept with this formula, P times H, you can just go through and find the area of every single rectangle and then add them all up. But basically, that's doing that, just in a formula way. You know what I'm saying? Okay, so find the lateral area of my regular hexagonal prism. What is my base? So what is my base? The hexagons, right? Okay, so what is the perimeter of my base? Because why?
6 sides and 5 centimeters.
5 centimeters each side times 6 sides gives me 30. And then what's my height?
12.
So I take 30 times 12,
360.
and I get 360. Now what's the label?
Centimeters squared.
It's still got to be squared, right? It's still got to be squared. Because we're still multiplying two things together that are the same.
Still area.
It's still an area, yes. Okay? That makes sense? Okay? So again, it's not overwhelming, but sometimes it does get confusing. So as Brandon asked, in case you didn't hear that part, if they don't put that word regular in there, then I have to go through and do the work of finding every single rectangle's area. Now in this one it says regular octagonal prism. So again, what are my bases? The octagons. Okay? So even though that they're not sitting on the octagons are my base. So what is my capital P?
24.
3 times 8. And then I take that answer times 9 because that's the distance between my two bases. So the height's kind of misleading because now it doesn't really look like a height, right? Because it's over on its side. But it's the height between. So if you really wanted to say, it's probably better if you say P times D, really, right? It's the distance between the bases, but it's technically the height. Because if you stood it up on those octagons, then it wouldn't. So what's my answer? 216, and then notice the 7 centimeters squared. Okay? Yes, sir.
So if you have like the equations, if we put LA equals PD,
PD, I'll accept 2. That's fine. Absolutely. I'm okay with that. All right? Questions here? Thank you. So now what's the surface area? So the first one is just the guts, the middle. Now the surface area is what?
Sum of the lateral area and areas of the bases.
Thanks. So it's basically the area of what?
Everything.
Everything.
All
Yeah.
sides, maybe?
Yeah, on the outside.
Is that okay?
Yeah.
Of all sides. So we're going to try to make this simple for you, though, and come up with a formula. So now, obviously, we're changing to surface area. Well, in surface area, I'm including the what?
Bases.
The bases.
Both bases.
So pretty much, I'm taking, but what else gets included?
Perimeter, height of that.
The perimeter and the height. So we could really say that I'm still going to use the lateral area. So that's where here, if you get this answer wrong and you use it in this one, well, obviously this one's wrong, but if you do the problem right, I'll give you the answer. You know what I'm saying? Because obviously it's not good if I penalize you for using that wrong answer because you didn't know it was wrong. Okay? So it's the lateral area plus what else?
Both bases.
Both bases. So how can I represent that?
2E plus LA.
Plus 2 and then capital B.
What's lowercase b?
Lowercase b would be a base, but it would be like base times height. Capital B means the what?
Both bases?
No.
Just the
Both is by the 2. So what's capital B mean?
just the base. Area of the base.
There. Area
Oh.
of the base. And that's why we say capital B, because capital B can change, right? It can be any shape that we want. So now we got to talk about all of our areas. Quick review. What's the area of a rectangle?
Base times height.
Triangle?
Bases times by 2.
Could be a trapezoid, but probably not. But trapezoid?
Base 1 plus base 2 times the height.
Divided by 2.
D1
Right.
plus D2.
Probably not going to do, not D1s. And then the last one that's going to happen is a regular polygon.
Yeah, 1/2
1/2
PA.
PA. Okay? So the regular polygons are probably the hardest. If we went back to that last shape that we had up on the board where we had an octagonal prism, then you'd have to find the area of that octagon. And that's where we use 1/2 PA. Okay? So you might also have to go through and actually find pieces of each of the things. Meaning, if you had a triangle, they might break it up where it is, you might have to find the hypotenuse, for instance, or you might have to find one of the other lengths of the sides by using trigonometry or Pythagorean theorem. Okay, everybody all right with all those words? Okay, so again, if it's a special right triangle, you're more than welcome to use that. If it's trigonometry, we're using SOHCAHTOA. Right? Okay? So let's go back and look at these ones. Any questions here? Now, if it's not, so if it's a surface area of any prism, are my bases still the same? They're still the same, right? Even if it's not a right prism. So again, a right prism means it's a regular polygon. So let's just say, yes?
Could you do me a favor, when you have an open moment, can you send Trevor to me, please?
Yes?
Thank you.
So your bases are still the same, but like in yesterday, if we had that pentagon where it was a house, all of my rectangles aren't the same, so then I got to go and figure out all of my rectangles. So basically, you can't do this P times A or H. You have to find each individual one, and then you could still use 2B though. Right. So when it's not a regular polygon at the bottom. Okay. So like for this right here, if we did this Kleenex box right here, I'd have to find the area of this and this and this. But actually I can simplify it a little bit, right? Because front and back would be the same. The two sides here would be the same, right? This would be the surface area of a rectangular prism where my bases aren't squares.
Could that work for anything now?
You can do that, yes, for everything. You could even do it for regular polygons. It's just, to me, it's more work. But that's totally up to you.
Yeah, because how would you...
Because then, instead of me doing the lateral area, I'm going to have area, and I'm adding them all up. That's how we simplify it by doing P times H. Okay? Here's another thing right down here. Okay? As you're going through the quiz and the test, your surface area should definitely be bigger than your lateral area. So it always shocks me, and it's going to happen, but somebody answers the question and their lateral area is bigger than their surface area. It can never happen, right? It can't. Because the ends are still included, right? So it's got to get bigger.
So can we, for surface area like formula, can we just put perimeter times height, or do we have?
Yeah, absolutely. You can just put P times H. Now, on the quiz and the test, you're going to have to explain your formula. Okay, so when I say explain the formula, that's what I would expect. P times H plus 2 times, and then you have to explain what B is. So instead of using capital B, because that's an easy out, right? Same way when we get to volume. Volume's really easy because there's one formula for everything. But then you can manipulate that formula into whatever you want. You know what I'm saying? So, if you're asked to explain, PH is fine with me. You could say perimeter and height, but then the B is where you would have to explain. If it's a triangle, then you would have to say, this is 2 times 1/2 base times height. But essentially, the 2's cancel out.
Yeah, so just be...
Right. So if you did just say that. Okay, so here's my problem. Oh, here we go. So, find the surface area of the rectangular prism. This doesn't specifically tell you that the front face and the back face is a square. But is it? It is a square, right? Everybody agree? Because if one's 6, then the opposite sides has to be 6, and the top and bottom both have to be 6. Okay, so this is a square. So this one works right here, of doing the area of all sides of LA plus 2B. Okay, so if you want to do the formula, the first thing I have to do is figure out my lateral area. What's my lateral area? So, again, remember what the lateral area is. What's the perimeter of my base? 24, because we did 6 times 4, right? And then what's the height between them? 12, so we'd have this. Plus 2 times, and again, why is it 2? Because there's 2 bases, the front and the back. Okay.
Why is it 64?
Say it one more time.
Why is
6
it-
times.
6 times 4.
Oh,
6 times 4 sides.
yeah,
Okay.
So
So this is my perimeter.
yeah.
And then what's my base?
36.
6 times 6, right? So again, it's the base of, or the area of the base, which in this case is 6 times 6. So we simplify, what's 24 times 12? Oh boy, right?
288.
288, that's what I got to do. Plus 72 equals
360.
360 what?
Centimeters squared.
Centimeters squared. Now, so what Aiden was asking is, yeah, I don't have to do any of that perimeter stuff, but then I would have to go and say, well, what's the area of this rectangle? Well, it would be 6 times 12, and then I would do 6 times 12, and then 6 times 12, and then 6 times
Will one
12.
of those rectangles be the same?
Right.
Oh,
So that's why I'm simplifying it by doing the perimeter.
I know, it's 6 times 12, you just do multiply by how many rectangles it be.
That's what we're doing right here. Okay? So yeah, it's just the way that you see it, but you said the exact same thing as this formula, you just don't like it as the formula's
Well,
written.
I think it's
Essentially.
just.
Okay? That makes sense to everybody?
Yes.
Okay? So, Trevor, you can go right now. Oh, come on. So here's the question. First off, oh, they do check. So don't say anything out loud for a second. Let everybody have a chance to think on this one. Is this a regular right prism?
Could be.
So basically, I'm asking you, is the triangle an equilateral triangle?
No,
No.
How do you know that?
because if you take half of 12, that's 6, and if you use the special right triangles, 1 square root of 3, 2, it doesn't add up.
Okay.
It looks like it will add up.
It does, right? So that's what we're seeing. A lot of people are going to jump to the conclusion that this is an equilateral triangle, and they're going to try to do this. But it doesn't work. So, did you understand what Riley said? Some of you look like your mind's totally blown right now. So, to me, I'm going to ask myself, well, what's the distance of this side right here? He used special right triangles. Okay? He's assuming then that each one of these is 60 degrees. So then when he draws the altitude, then he would have a 30, 60, and 90. And then he did his 1, 2, square root of 3. Another way, if that totally confused you, then I would do Pythagorean theorem right here. So I know when I draw this red line, what does it do to 12? It makes this 6, right? So then I got 6 and 8, and then I can find my hypotenuse.
Your hypotenuse has to be 12 for it to be equilateral. So
Right.
it's 12.
So in this case right here, 36 plus 64 is,
100, so it's
should be. 6 squared is 36 plus 64, right?
1 time.
Isn't it 100?
It's 100.
That's why I said you said no.
Oh, sorry, I misunderstood.
So it's 10.
It should have been 10,
Yeah.
right? So if the hypotenuse of that triangle is 10, is it an equilateral triangle?
No.
No. Now, is it an isosceles triangle?
Yes.
Yeah.
Right? Because if it's a 10 on one side, it's got to be 10 on the other side. Okay, so when I do this problem right here, I don't have my regular polygon, right? So I can't use this formula right here. So what is the perimeter of my triangle?
32.
32.
10 plus 10 plus 12, right? And so what is my lateral area of that? Of this shape?
32 times
32 times
320.
32 times what? Oh yeah, 10, sorry. I thought it was 12.
10. So 320.
So 320 is my lateral area, but does everybody see why that is and how we got that? Okay, so now I'm going to take this for my surface area. I'm going to still use my 320 and I'm going to add it to 2b. What is b in this case?
48.
Why?
Because you can take half of 8 times
12
12.
times 8
Base times height divided by 12.
divided by 2.
Yeah.
Right? So, but we have 2 of them. So if you wanted to do really say this should have been 24, right? But then I'm gonna multiply by that 2 and get 48 again, right?
No.
12 times 8, you did the 48 already.
Yeah, so it'd be
96, right?
96.
So this would have been
That's
96
48.
48.
That's 48.
divided by 2, which got me 48. But then I have to multiply it by 2 because why? The front and the back.
So it's 96.
So it ends up being 96.
You really don't have to worry about
320 plus
Right.
96.
So my 2 2s actually cancel each other out.
Where did you get the 32 from?
Yeah.
This 32 was the perimeter of that triangle. So when we did Pythagorean theorem, we found out that this side right here was 10, and this side right here is 10. Okay? So then we said 10 plus 10 plus 12. Okay? Alright, questions here? How much time we got?
So then your surface area is just
4
minutes.
minutes.
Alright, 4 minutes. It's 320 plus 96.
Plus 96.
Yeah.
Yes. Then you'd have to add those together, yes. And then don't forget it's still an area, so whatever square.
Wait, but I thought you couldn't do that for 32 because it's not an arguable polygon.
But we did it in a different way. No, we actually figured out the perimeter.
We do lateral.
We actually added them up, 12 plus 10 plus 10.
Oh, you didn't just.
You're always going to be able to do the
Oh,
perimeter.
okay.
This one, the perimeter, and they're all the same, but I still found the perimeter.
Oh, okay. So you can always do the perimeter time for this.
Yeah, I can always do that formula. It's just, some of them, when it's a right prism, it's going to be perfect in a sense. So all of them
It's
I
just
have the same
easier.
size.
It's just-
It's easier in a sense. You got to do a little bit more math.
Yeah.
Well,
Okay.
So like,
So you never really have to talk about.
saying if it was like, regular.
If they would have told you that that was a regular triangular prism,
What would we have done different?
just the prism, or I mean just the perimeter would have been different.
Oh, okay, I thought you said that it was just all this.
Because now we actually did the perimeter.
But we did the Pythagorean theorem, then the perimeter.
Yes. But see, in this perimeter, we didn't do, in all the other ones, the perimeter was the same every, or not the perimeter. The side was the same every time. So each of my rectangles were the exact same. In this one right here, when we have, like on the bottom, we would have done 12 times 10.
Yeah.
On the side, this side, we would have done 10 times 10. And then on the other side, we would have done 10 times 10. So realistically, we're still doing everything times 10, so we can still add up all the sides, but the sides aren't all the same. In the first one, we had them, all of them were 6 in that way.
But like, yeah, well, we didn't have to do Pythagorean theorem in the case, because 10 would have been the same for that whole, that rectangle. Or looks like a square. I don't know.
On the right-hand face,
Yeah.
yes, we didn't do Pythagorean theorem for that. We did
No,
Pythagorean.
I'm saying like, we really didn't need to do it for the triangle, but we found out it was. Because we.
But we didn't know that side right there was a square. So you did have to. Okay? So, we're still not done with this section. Okay? The lateral area, don't say this out loud, let everybody have a quick second to think about this. Lateral area is what part? Everybody got their answer? What part? The guts, right? The middle part. Don't include the bases. So the first thing you got to figure out is what kind of prism it is. And if it's not a rectangle, then that will be your bases. And so you're going to take, usually the lateral area is always what shape? A rectangle. It will always be rectangles, but sometimes it's a rectangular prism, so then you have to do your rectangle. I was doing some of these problems today for a little thing that we're going to do down the line for you guys. So I was looking at this. Realistically, if you have a rectangular prism, there should be 3 different numbers on the problem. You're going to multiply all the numbers in every combination that you can and then take it times 2. Because it would be the top and the bottom, the left and the right, and the 2 ends. That's another way of thinking of a rectangular prism. Okay? And then we did the surface area, which just included the what? The bases, right? But we included the bases with the lateral area, but it's essentially everything. So we compared it to wrapping paper. Today we're going to talk about a cylinder. Because realistically, a cylinder is essentially a prism, but why is it easier?
Because it's two circles.
Because it's always the same thing. The formula for lateral area and surface area is exactly the same thing for every single cylinder. That's why it's nice. Okay, but before we get to this, so a cylinder is simply a prism, and I'm going to put it this way, right, in quotation marks, because technically it can't be a prism, because why? Because it's got a curved side, right? But a prism with bases as circles, right? That's what makes it our easier, I guess. Now, before we do this, though, we need to introduce two more things. We need to introduce an axis first.
Is this still 12 Yes. It's 12
The axis of a cylinder, okay, is kind of like the axis of your car. So what's an axis? It connects the what?
Wheels.
The wheels, right? So if the wheels, oh yeah, an axle. This is an axis, but
Same thing.
yeah, you kind of get it, right? Most people didn't even notice it until you brought it up. See? So if it's an axis, it acts as the axle. So just like an axle, it's connecting the tires, which are essentially circles. The axis is going to do the same thing in a cylinder. So the axis is going to be a segment between the bases that connect. What do you think it connects? And
Everything.
what would it connect in an axis or an axle?
Centers.
The what?
Centers.
The center of those circles, right? So it connects the centers of your circles. Anybody else?
Yeah.
It's
Just
strange.
point the fan away from Geom.
Actually,
Okay, so what does this remind us of from yesterday, though? Essentially, this is what we kind of talked about as being the what in a prism. The height, in a sense, right? So this is, though, exactly when it's in the center to the center. So here's the difference. If it's a right prism, what did we mean by a right whatever yesterday?
Right angle.
It formed a right angle, but on the ends it was also a what? A
regular volume.
regular polygon, right? So they're perfect in a sense. Okay, if it's a right cylinder, here's my cylinder. Okay? My axis is going to connect the two centers and form a 90-degree angle. Okay, so in a right cylinder, this is my axis, but it's also the what? The height. And then yesterday we also introduced what besides a right prism? What was that other word? An oblique prism. And what was true about an oblique prism?
They just say parallel.
They're still parallel, but they're on the slant. So Riley said we have to draw it at two dimensionals, right? So we end up doing this. Right? So this is my oblique cylinder. My two circles are just still parallel to each other. We still have an axis, which is in the middle. Okay, so this is still my axis, but now my height has to be where? My height has to make a right triangle. So my height is going to be out here where we can draw that dashed line. So you might see a couple of these in the homework today. Okay? Don't get confused when they talk about the axis. In a right cylinder, they're the exact same thing, which the majority of ours are. So we need to get back to the formulas, right? We're talking about lateral area again versus surface area. So the lateral area is still my guts, right? Yesterday, what was the formula for the lateral area? Capital P times H, right? Or we came up with capital P times D yesterday. D could replace that H because it's really the distance between the bases. And some of you didn't like it when it was on its side, so we called it D. That's okay. Well, this is where it gets easier because if we're talking about the perimeter, perimeter in a circle is always what? 2 pi r or pi d, right? So whichever one you like better. And then we're going to multiply it by the h. That's the lateral area every single time for any cylinder. Because it has to be a circle, right? And the perimeter of a circle is the circumference, which is either one of those. And then we're still going to do the distance between the two circles. So it's the exact same formula from yesterday, but we can simplify it right off the bat. And then with our surface area, we're still going to use the same thing. So whichever one you like again, 2 pi r h or pi d. Because remember, what was surface area? It was the lateral area plus what? 2 capital B, right? And why was it 2? Because there's 2 bases, one on the top and one on the bottom. And why is it capital B? It's the area of the base. But now we can simplify that because we know what the base is every single time in a cylinder, right? So what's the area of a circle? R squared. So we're going to say plus 2 pi r squared. And then obviously you could do the same thing down here if you like pi d better than 2 pi r.
So what is that? What the LA plus 2B equal?
This is what we did yesterday. The lateral area, which is over here, which is really perimeter times height, plus 2b, which is the area of the base.
So what does that find?
This is my surface area. So remember, it's always the area of the base and the perimeter of the base. That's more for yesterday's because of our shapes, right? Because yesterday our bases could change shape.
The bottom one have pi d, does it have to be an h?
Oh yeah, we need h. Good call. Thanks. Pi times diameter times h, the height. So this is still surface area, whichever one you want. And these are all lateral area over here. So essentially, it's still pH and it's still LA plus 2B, but we're simplifying it because we know what it is every single time. Does that make sense? So again, when you have to write this formula down, I want you to be as specific as you possibly can. So you either need to write this or this instead of LA plus 2B. You have to describe what all those pieces are. So my lateral area will always be 2 pi RH. I don't know, I always go to this one.
How do you find the area of the base?
How do I find the area of the base? Pi r squared. Because it's a circle. Okay? That's why we were kind of happy you weren't here yesterday, because it was kind of confusing to some.
It was, I'm more confused now.
Gabe, you just broke your lead and it landed on my desk.
Nice.
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 It flew in the air on my desk.
Alright, here we go. Whoa. Where's the shape? Find the lateral area and the surface area of the cylinder. Round to the nearest tenth. There's a shape. Everybody agree it's a cylinder?
Yeah.
Right? It's a prism. It's got a circle on the top and one on the bottom, so we call it a cylinder instead of a prism. Okay, so. Say it one more time.
It still stays perfect.
No, because a circle is a circle. Right? A circle realistically is a perfect shape.
It can be an egg.
Like the dot's always going to be a central.
Yes.
Why?
Yes. The only time that this isn't going to be perfect is if it's on a slant, like this oblique one.
In that case, you have to do from
then you probably have to use Pythagorean theorem or something. Okay? So, let's go to work. 2, which one do you want to use? The top one or the bottom one?
Top.
Top one. So, do we got all the information? 2, pi, what's my R? What's my H? All of that, when they're written next to each other, just means I do what to it? Multiply them all together. So write that number down. Then I gotta come over here. Remember, this is a little bit more of the order of operations, right? So R squared, in this case, would be what?
14.
So what's 14 squared? 196 times 2 times 5.
Wouldn't it be,
I can go in any order I want, right? The most important thing, though, is that I square my radius first. Well, technically, you can take 2 times pi if you want.
I'd probably do that first.
Okay. And then, at the very end, you add those two things together. So, what'd you get for just the lateral area part? Lateral area. Shouldn't have been that big. Should have been.
How do you find that?
Right here, buddy. That formula right there. The pH is the same thing as this. Those two are the exact same thing.
That's the starter one.
The perimeter of my base is 2 pi r. The h is the height between the two bases. That's what we did yesterday. So, what'd you get? 1,583.4?
yep, exactly.
Now, again, remember, if you use the pi button, do not round until the very, very end. So, if you use the pi button, this is probably a little different number. No? Still the same? Okay.
Next one might be.
Here we go. So now we do this formula, 2 pi rh. So we just did this, right? So you're going to use that number, but now we have to do 2 pi r squared. So when you did your math, you should have got a grand total of 2,814.9 what? What was it?
inches.
Was it?
It was feet. It was feet.
Boy, you're just throwing out shit here. Feet squared. Why is it squared? Because we're still just finding an area, right? So even though that we did a lot of things, it's still just an area. So it's feet squared. Okay? Now again, I usually don't count it off when you're going so fast that you put centimeters in for every single answer. Some people have done that, right? So you realistically slow down and look at the shape. You know what I'm saying?
You.
So a couple things that could happen would be what? Well, again, they could give us, now this is again pretty much the same thing, but what could happen different? One, they could give us a diameter. So then you have a decision to make. Do you go back to, or do you just use this one, or do you go back to this one? It doesn't really matter, you're going to get the same answer, but if you go back to this one and they give you a diameter, the first thing I got to do is divide by 2. Okay? And then with these oblique ones, you might have to find one of those other numbers. Meaning, if they give you the length of this, and they gave you the axis, you might have to find that height by doing Pythagorean theorem. Or you might have to use some kind of trigonometry. Now those are getting a little bit more complicated, and I think you'll see more of the oblique things when we get to volume than when we do lateral and surface. Okay? But essentially it's the exact same formula, we're just manipulating it today a little bit. Okay? Do we need to go through this one? Okay? Does anybody have any other questions?
That's the whole lesson.
That's the whole lesson.
Well, you missed half.
Is the answer
You
yes?
missed half.
You missed two of the
This one you think is A?
Yeah.
It's A.
He cheated a lot.
No, it's not.
He definitely
have
cheated.
all the work right here.
Attaboy. Alright, so the rest of the time you get to work on some problems. We will have a bell ringer tomorrow over this, right? Hold on one second.
That's all we got today for 12-2 surface area.
You're gonna have to
Here's
make that
some
up,
cylinders.
okay?
Say it one more time, bud.